Oh, well then, fancy meeting you here at the Daily Space Weather. And thanks for tuning in. Congratulations on realizing the channel exists. The story once again today is Filaments. Accurate forecasting. New sunspots rise in the east. And plenty more to cover. Here at the Smash News Network, least busted name of news. These videos we started things out with are 24-hour SDO videos. That's the Solar Dynamics Observatory. And the wavelengths featured here are the extreme ultraviolet emissions of ionized helium in 304 angstroms and ionized iron in 193 angstroms. Again, the story, the main story at least, for solar activity is filaments. And my, have we got some spectacular imagery today. So there is a view of some of those northwestern ones. The crown prominence up near the top. Crown prominences will become more and more common as we get closer and closer to solar maximum over the next approximately 1 year's time. That gives you some idea of the size of those plasma filaments. Here's the equatorial zoom, and you may see some action over there at the northwestern limb. There were some quite spectacular CMEs that popped off. One of those right after our premiere of the Daily Space Weather Show yesterday. So once again, here is the western limb. There's just the western limb by itself. And for completeness, we've shown the southern hemisphere, the southern polar region. Some crown prominences down there as well. Here's an extreme close-up of the one in the southeast. And here's the eastern limb where we saw two new sunspots rise. So you can see one right at the end of the video there popping up below the Earth scale, and one a little bit earlier popping up above the Earth scale. The South Pole heliospheric current sheet is also almost here. We will cover that as well. Also a coronal hole high-speed wind. So plenty of space weather activity here following quite a significant lull. Here's that new sunspot we forecasted in the northeastern limb. And we'll tell you about how those forecasts occur a little bit later in the video here. And here's an extreme close-up of that new sunspot group. Might only be a single umbra. We'll cover that a little bit later in the video as well. What's that? The last close-up wasn't close enough. All right, there's a closer close-up. So here's a brief look at our SDO intensity gram. That's yesterday plus today, August 17th and August 18th to date. Here is our SDO colorized magnetogram. And you can see those active regions rising there, both in the northeast and in the southeast. The northeastern sunspot much more well-defined than the southeastern. And let's take a step back to take a look at what's going on croissant Earth. Yeah, Earth. It's shaped like a croissant, folks. Stop believing NASA's lies. Pardon my sarcasm. This is one of the slopes here of the Aniakchik volcano. Some high mineral content sulfury lake water there at the lower slopes. Perhaps some geothermal venting activity happening down there. Here's a list of erupting earthquakes. Sakurajima is producing a 4,000-foot ash plume. Mayan, unknown volcanic ash plume there over Luzon Island, Philippines. It has been erupting fairly ferociously over the past month or so. Semeru also exploding, flight level 150. That's a 15,000-foot ash plume over East Java. Please do not pole vault the caldera. Aniakchik on the Alaskan Peninsula here. Let's see, what do we got? Background seismic activity has declined. The Volcano Observatory has lowered the alert status to green at Aniakchik. Santiaguito, no volcanic ash emissions observed there over Guatemala from it. However, Fuego's exploding in that same nation. Flight level 170. It's a 17,000-foot ash plume. 22,000-foot ash plume over Ecuador as it explodes. 15,000-foot ash plume over Revenador as it explodes. Sabancaya exploding. Flight level 250. It's a 25,000-foot ash plume over Peru from it. Ubinas in that same country exploding as well. Flight level 230, 23,000-foot ash plume. And let's talk about earthquakes. We did have at least one 6+ magnitude over the past 24, and that one would have caused some damage. So there is the past 90 days. Here is the largest quake of the past 24. It was a 6.1, I believe, here, felt in both Medina and Bogota, Colombia. Likely caused some damage and destruction, as building codes are not like they are in Japan and California in Colombia. So there's the location of that quake. That was a 6.3 magnitude at 17:04 Universal Time yesterday afternoon. We'll call out quakes that are above a 5 and higher. So Tonga had a 5.2 at 16:31 Universal Time. Central Mid-Atlantic Ridge, that's a very large quake for the Central Mid-Atlantic Ridge there. A 6.0 there, right near the surface at 10 kilometers estimated depth. Only 10 minutes after the Tongan quake. 6.0 there at 16:41 Universal Time. And then the largest quake was that 6.3 at Colombia. And of course, aftershocks can be expected to continue there. Hoping that 6.3 is not a foreshock. Doesn't look like it so far. And then a lull in 5+ magnitude quakes until yet another foreshock occurred. And Smash Staff and I, we think we felt earthquakes the past 2 days here in Pennsylvania. But no indication of it on the list, so not sure on that one. The ground shook. There was no thunder or lightning around. And it happened, I think, around noontime both days. Anyway, also a 5.7 aftershock there at the Mid-Atlantic Ridge. So a significant uptick here in seismic activity since yesterday. Also a 5.4 off the coast of Peru. That rounds out our list. And getting back to the weather in space here, there's the past 24 hours of the closest star in the house favorite wavelength, 171 angstroms. It shows the lower corona. And it is another species of ionized iron. There's a spectacular equatorial zoom for you. Hopefully you're watching these videos on like a 90-inch television. And part of the reason we make the videos is so that we can watch them on a large TV. That's how these videos originated back in around 2017. Here's that new sunspot that rose in the southeast. And here's a 24-hour video of the northeastern sunspot. It's at quite a high latitude, an indication that we still are not at solar maximum. At solar maximum, you can expect to see sunspots at pretty much all latitudes, from high up close to the polar regions all the way down to the equator and back again. So taking a look at some space weather stats here, the 10.7, otherwise known as the F107, the 10.7 centimeter radio flux, which is emitted from the upper chromosphere and lower corona, right about where my arrow is here. That is a directly proportional data set to the sunspot number. In other words, when you have a high sunspot number, you have a high radio flux. As the hydrogen gets excited, there's the 1-year graph of the radio flux represented by the black line. The red line, the sunspot number here, another little dip in activity, preceded by a big uptick in sunspot number there. As you can see, it dropped all the way down to 61, I think that is, and then came all the way up to 140 rapidly, which is a common thing throughout a solar cycle. Now, we did see a significant strengthening of the magnetic fields, and we do have a coronal hole high-speed stream. However, it's not expected to produce any geomagnetic storms, at least not according to NOAA. And if we do have further shifts in the magnetic fields, we could see geomagnetic storm conditions based on the density and plasma velocity. Next, we'll take a look at the Earth's magnetic moment from space here for the past 4 hours. There's the Space Weather Modeling Framework's magnetohydrodynamic pressure model. This Geospace Magnetosphere movie brought to you by University of Michigan Geospace Model V 2.0. That's the past 4 hours of Earth's magnetic moment from space. It depicts nanopascals, magnetohydrodynamic pressure out to about 12 Earth diameters. Here's Earth's magnetic moment from the ground, and we may see some auroral imagery being shared. We'll tell you the best place to share it if you've got images of the aurora a little later in the video. Follow us on social media. We're all over the internet on social media. So that's the past 4 hours of Earth's magnetic moment from ground level. It depicts magnetic flux density. And those spots that are lighting up there, those are the most likely places to see the aurora. We've tested this out and seen the aurora in surprising locations during minor geomagnetic storm conditions. KP index currently at 3, a little bit of an elevation there in Earth's general global geomagnetism. Planetary K index, KP3 is the current situation. And here's the solar wind. And we have a legitimate coronal hole high-speed stream. So we have the telltale signature here, which is an increase in the solar wind density, followed by a decrease in the solar wind density, followed by an increase in the solar wind velocity, and typically there is a plasma temperature signal there as well. So all of the features that you'd expect from a coronal hole high-speed stream. And if you are hoping for aurora, unfortunately this top line is not going to help you because the BZ, which is the vertical component of the magnetic field as measured at Lagrange point 1 by in this case, the ACE spacecraft, has moved into positive territory. So that's more of a push than a pull. And when we have a negative BZ, that induces more electrical current into the earthly system, which is more likely to produce aurora and geomagnetic storms. At the moment, the BT is 10 nanotesla and the BZ is positive 8. Solar wind density here, just over 4 protons per cubic centimeter. Solar wind velocity, 438 kilometers per second. And here are our GOES magnetometers. So not a big shakeup in the GOES magnetometers, as that was a fairly mild coronal hole wind stream impact. It was not preceded by a huge density spike. So, but it is fairly average as far as coronal hole high-speed streams in terms of its magnetic fields, velocity, and plasma temperature. Moving on to our top view ecliptic plane field plot, and I say it all the time, that this is one of the most important pieces of data to understand. So we were talking about how the North Pole current sheet here was being kind of obscured by a South Pole current sheet, which caused me to theorize that there was going to be a sunspot rising in the northeast, which is exactly what happened. However, one also rose in the southeast, and now there's a North Pole current sheet. Just about here. It'll be here in a couple of hours. It's depicted by this green potential field surface source lines. So Earth is about to leave the South Pole current sheet, snap into a North Pole current sheet, but it might be brief as there is another South Pole current sheet, only about maybe 36 hours behind. And it all depends on the performance of those sunspots. And again, you may be able to actually use this potential field surface source model data to forecast how those sunspots will evolve. We've shown it again and again on the channel over the years. There is huge predictive value in the top view ecliptic plane field plot. Next, our line of sight field plot. There's the solar B field depicted in blue, polar fields in green for north and red for south. And you see that B field moving around there. I'm talking about this portion of it right over here. As sunspots will affect that, especially since they can form quite rapidly. So the magnetic environment can change with essentially no warning. If you're watching our channel, you might have some warning. You might have some advanced knowledge and ability to forecast space weather if you watch our channel. It's only the most comprehensive daily space weather in the world and the most detailed imagery of the sun you'll find in the known universe. So we've got multiple coronal holes here. Let's bring this to the last image before we show an SDO 24-hour video. So looking at the last image here, we've got South Pole coronal holes except for in the southeast. So looking at SDO 211 angstroms for the past 24 hours. So these are south. And down here, we've got some North Pole coronal holes. There's a sector boundary crossing somewhere around here. And we'll let that play through for your viewing pleasure. 211 angstroms is another of the many species of ionized iron depicted by the SDO. And different numbers of electrons in the iron's outer shells cause those highly heated gases to behave differently in the sun's atmosphere, known as the solar corona. That's why the different wavelengths feature such different features. They feature different features. Yeah, that's a thing. Next, moving to sunspots. So that's the situation. The likelihood of solar flares does go up a little bit here. However, it has been very much underperforming for the past few days, maybe 5 days or so. We've seen quite a low number of solar flares, and it's been a long time since we've seen even an M-class flare here. The magnetic complexity of these new groups will affect things, and we'll show you that before we get to our meteorology segment. We like to tie your space weather and Earth weather together on the channel. So let's take a look at some of our custom videos here. This is the SDO 24-hour magnetogram, approximately 24 hours. And you won't see any major changes happening here. Most of these groups have been stable over the past 24. You will see the rising of that new group, especially in the northeast, and barely see that one rising in the southeast. Here's SDO continuum. And there may be some more new small sunspot groups here forming. They are pretty minor. We're not really going to spend too much time concerned about that, as there are bigger fish to fry. No offense to Jaws, Bubbles, Ricky, and James T. Kirk. Next, we'll cover energetic particles and solar flares. We ain't got no energetic particles. The GOES proton flux here, as measured by the GOES 16, is flatlined. The solar flare profile here, down to a B-class range, about a B9, is the background X-ray flux. We've only seen C-class intensifications here. We are way overdue for an M-class flare. And really, the sunspots that we have here are not all that magnetically complex. There is still some likelihood of M-class flares, however. And let's take a look at some SDO wavelengths that are good at producing solar flares. I should say SDO wavelengths that are good at depicting solar flares. So here we've put 131 angstroms along with the 171. That shows great detail of the magnetic filaments that cause that plasma to be suspended and defy solar gravity. Here we've subtracted the 171 and added 94 angstroms. So there are two more species of ionized iron there, 134 and 94 angstroms. So there still is some likelihood of a large flare in the northwestern limb up here. That will be subsiding here over the next about 24 hours. So by the time tomorrow's daily space weather video comes out, the likelihood of a large flare up there will be dropping. That has been the most active region for the past 24 hours. Next, we've got just a basic star chart for you here. This is skyandtelescope.org's star chart. You put in your location, you press the Now button, and it'll show you what's going on overhead. Jupiter high up in the sky there on the ecliptic, as Venus has just recently become a morning object, because it's not really a star. People used to think it was a star, but it's what we call a wandering star, which is kind of what planet means or something. So that's what's going on over Lehigh Valley, Pennsylvania, where we are located. A sliver of a crescent moon is just peeking up over the horizon here at the moment, following the August new moon. Here is your solar system forecast. That's where things are today. We've got a crescent waxing moon. We'll advance this 1 week. That's where things will be in 1 week. We will have a gibbous waxing moon by that point as we enter into second quarter. I don't know. I'm not really too concerned about moon phases. But that's the situation for the solar system. If you haven't checked out Zooniverse.org, Zooniverse.org, the world's largest citizen science project, highly endorsed by the Smash News Network, least busted name in news. Let's classify a galaxy, as we need humans to classify galaxies, as it is too hard for AI to do this job. So AI is not taking over the world anytime soon. It's just a good use of technology when it works, when it's not biased, and when it's not full of crap. So Galaxy Zoo is certainly not full of crap, and we know you're not full of crap, so why not go classify galaxies? Just set up yourself a profile over there like we did. We've classified hundreds of galaxies. And here we go. So this is the deal. You only classify the object in the center of the frame, folks. And so this one is definitely features. It is definitely something else. It definitely has no bar. It definitely does not have a spiral arm pattern. Is there a bulge? I don't think so. I'm going to say no bulge. Are there any obvious bright clumps? Well, there looks like there is, so let's say yes. And then we're going to say it's oblong, so we're going to say minor disturbance. And then for features, we're going to say irregular, lens or arc, dust lane, overlap, and poof, that galaxy has been classified. Zooniverse.org, the world's largest citizen science project. Next, check this one out. Totally sweet. Did you ever wonder what Pluto looks like up close? Yeah, did you ever wonder what Pluto looks like up close, folks? Well, we'll show you. Check this out. This is splentacular. Here's the North Polar region of Pluto. Yeah, Pluto used to be a planet. Did you know it's the only planet in the solar system named by an 11-year-old girl? For real. Yeah, it's named after the Disney character Pluto. I think. Is that right? I don't know. There was some kind of a contest to name it or something. There is the northern polar region of Pluto. And if you're wondering what the chemicals are there, they are things like methane and methane ice and nitrogen ice. So that's part of the color variation that you're seeing there. Of course, Pluto is a very small body. That was this imagery from the New Horizons spacecraft. Pluto is about 6 billion kilometers away from the sun. Here's another close-up view of the surface of the former planet. And of course, Pluto does not orbit the sun in the same orbital plane as the rest of the planets do. That's part of the reason why it's not really considered a planet. It's thought to have really not been part of the original protoplanetary disk in which the rest of the planets formed. Its orbit actually goes through the ecliptic plane, not on the ecliptic plane. Last but not least, a little interesting cosmology story. So this right here, this is a supernova remnant. And somewhere within that supernova remnant, I'm not sure if it's this bright area over here or this single bright point of light over here, there is a neutron star in there traveling at something like 1,500 kilometers per second. So just to give you an idea of how fast that is, the solar wind is currently at about 500 kilometers per second. That's about 1 million miles per hour. That neutron star is moving at something like 3 million miles per hour. So Yeah, neutron stars. Sometimes they behave like comets. And if you want to read more about that one, we've talked about this before on the channel. By the way, on our Cosmology Segments playlist, you can see videos about other neutron stars that have been found to be blasting through the galaxy at crazy solar wind level speeds. It's been covered before. It's a well-known thing. This article from New Scientist here. This object is known as... It's got a catchy name, folks. It's called... There we go. It's traveling at a speed of 1,130 kilometers per second, and it has the catchy name of PSR J0002 plus 6216. It is also a pulsar, meaning it has rapidly pulsing magnetic fields. So that's a little cosmology story for you. That should amaze and perhaps frighten people, as neutron stars are able to behave essentially like comets, traveling at very, very high speeds. It is not fully understood how they do this. And let's move on to our coronagraphs. Here are 101 frames from George Mason University, and you will indeed see some coronal mass ejections happening there. We do not anticipate these to be earthly directed. They're directed off to the west and off to the south. That's 101 frames from yesterday. Here are today's frames. There are 24 more frames from today. And expect coronal mass ejections to continue. The likelihood of them continuing, the likelihood of us seeing more coronal mass ejections between today and tomorrow is 99.9%. Just this side of 100%. It is possible for no more to occur until tomorrow, but it's very, very unlikely. Here's LASCO C2 and C3, and we have an update on what's going on with Stereo A. How do you like them apples? Yeah, we figured out what the deal is with Stereo A. We're actually going to show you some images from Stereo A. It's still working. It's not broken. I know why the images were looking so weird. It's just a matter of reading, folks. It's not that hard. So if you go to the Stereo A website, we show this diagram daily because Stereo A is practically right in between Earth and Sun right now, which does not help with calculating coronal mass ejection trajectories. However, check it out. If you read what's above this, where is Stereo A today? Stereo A has changed its positioning in order to keep its high-gain antenna oriented toward Earth. So Stereo A is not used to having itself right in between Earth and Sun. It's sort of the most uncommon scenario. Hasn't been anywhere near there since its launch in 2006. It's made one complete solar orbit, chasing Earth as it does so. So here's a Stereo A coronagraph on the left. And it might look a little bit jacked up, so let's close that out now. We're going to show you what to actually view. And we're showing Soho LASCO C2 and C3 again. So let's take a look at those CMEs, since they were quite spectacular. We'll back this one up to yesterday around 1300. That one started to come out of the Soho LASCO C3. There it is on the C2. It's a very dense CME, and it looks like a lot of that material either stayed suspended as a plasma filament or collapsed back down toward the chromosphere, the layer of the sun in between the corona, the atmosphere, and the surface known as the photosphere. So there's that rather bubble-like CME. There's like a second outflow that happens there as well. Not likely to be earthly directed, not likely to have any earth-directed components. Although there is a more stealthy eruption down here in the southeast, again, probably not earthly directed. So here's the view that you can get of Stereo A, because as it says on the Stereo A website, the difference imagery is mostly unaffected. So there you go. There's some corroborating coronagraph imagery for you there. Use the Stereo A difference imagery, which is available at the same Integrated Space Weather Analysis Center website, the ISWA. Still a little bit oriented off of the center there, but These are the sacrifices that you must make in order to keep the thing communicating with Earth. If its high-gain antenna wasn't oriented directly, you wouldn't get any imagery at all. So that's what's going on with Stereo A. That mystery has been solved by simply reading the Stereo A website. Yeah. Remember, folks, extraordinary claims require extraordinary evidence. So this is a common thing, and when people argue and bicker on social media, try not to fall victim to too much of that nonsense. Here's a 24-hour video that we put together here featuring the SDO 193 angstroms wavelength and the Soho Lasco C2 and C3. Great views of those CMEs out of the west. Here's a little closer view of that. What's that? You want an even closer view? All right. There you go. And next we're going to move to filaments. So here we'll get rid of the Soho coronagraph and just show 193 angstroms. So that's a pretty good wavelength for showing filaments. And let's move to the El Teide, Spain ground-based solar observatory, which is even better at showing filaments. And did you know we've been naming plasma filaments after living people? Why? Because, well, they're naming winter storms now as well as hurricanes, so how about plasma filaments? They are often the source of space weather, so why not? It seemed like a brilliant idea. If you want to name filaments after living people, go join us on Twitter. I'm not calling it X. X is not a brand. I'm calling it Twitter, period. And here is the grayscale, which does show prominences, and you'll see lots of prominences, especially on the western side. So prominences are just filaments that are at the edge of the solar disk. Of course, they show splentacular detail there. So follow us over on Twitter. If you've got images of the aurora or stories you'd like to cover, go tag us over there. If you want to name filaments after living people, follow the hashtag #NameThatFilament. We've made it a thing. Hashtag #NameThatFilament. Here are the past couple of hours from the GOES 16 SUVI. And dare I say, filaments, filaments, filaments are the story? Check it out. Filaments are definitely the story. So we make sure to cover this from a holistic perspective. And if you want to learn stuff you didn't know about science, folks, immerse yourself in the data. You may end up with answers to questions not asked, which is what has occurred on this channel. Answers to questions not asked. I wasn't trying to explain the solar sunspot cycles, but I received answers to questions not asked, and so I think I have explained the mechanism that underlies the solar sunspot cycles. It's pretty serious, and let's move on to bonus features. Starting with satellite charging hazards, we've got some significant surface charging hazards here over the eastern Atlantic. Those are low-energy electrons that are building on the outside of spacecraft, so you could see some communications issues there with those spacecraft. Not likely to produce internal errors, but communications issues, as those create magnetic fields on the outsides of the spacecraft, and they can affect their communication. Surface charging hazards there in the eastern Pacific. The GOES electron flux here cratered as you would have expected if you're used to watching our channel. Coronal hole high-speed streams tend to crater the electron flux. It's essentially an anomalous reading, folks, as the incoming solar plasma does cause the ionosphere to move. The GOES electron flux is measured using radiography from the geosynchronous orbits of the GOES 16 and GOES 18. The N's and M's stand for noon and local time for the satellite. Noon and midnight local time for the satellites. There's the one-year graph to put it in context, and no surprises there. The electron flux is in a trough right now, which is what you see when coronal hole high-speed streams and CME impacts happen. Here is the forecast model by NOAA. The green boxes are the forecast, and the yellow diamonds are the observation. NOAA is expecting a downtick here to continue for the next 3 updates. I think perhaps this will start to rise earlier here, so that third one will probably be a little bit higher, but hey, not a big deal. Again, it is measured at the F layer of the ionosphere. So let's take a look at that. And feel free to pause the video on this frame if you're not familiar with the temperatures of atmospheric layers, the electromagnetic radiation penetration, and the chemical concentration of those layers. Here is the vibrational frequency of the bridge between Earth and space, the F layer, which is located at like 300 kilometers of altitude. We'll also show the anomalygram. This is raw vibrational frequency here. Millions of vibrations per second. And here is the anomaly in megahertz from the 30-day median. Again, this coronal hole high-speed stream has been rather minor. So you are seeing some pushes happening here and that. A lot of blue areas there. That's low-frequency anomalies. The red areas depict high-frequency anomalies. I'm sorry, I've got this backwards. The blue areas are high-frequency anomalies, and the red areas are low-frequency anomalies. That's what I meant to say. So those high-frequency anomalies there in blue, those are like pushes, and the low-frequency anomalies are like pulls. They are high and low spots. In the ionosphere, as it does have a three-dimensional structure here. I know it's not super obvious in the two-dimensional model we're viewing. Here's the latest image. That's 12:30 universal time for the ionogram and 12:30 universal time for the anomalygram. Total electron content is free electrons from about 12,500 miles down to the surface level. About 12,500 miles is where your GPS satellites are located. When they have to communicate through a lot of electrons, there is signal refraction, which is what's shown here, the total electron content forecast, the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. And if your GPS is likely to produce errors and you need to navigate, if there are Wi-Fi hotspots, they have known physical IP address locations. So if you turn on Wi-Fi location accuracy, that can help you navigate. And if you're in an area with no Wi-Fi hotspots, you'll be SOL. So out of luck. So here is the total electron content anomaly from the 10-day average over North America. We are seeing continued anomalies here over the western North American continent, Mexico, and Central America. So that's the anomaly from the 10-day average. And let's close out space weather with the latest imagery from SDO. So first we'll look at this new sunspot. And it looks like it's only an alpha class sunspot, folks. It's pretty big size, but it's only alpha class, meaning it's looking like it is not magnetically complex. So that's not likely to produce a large flare, at least not from the imagery we see here. Let's check out this new sunspot down here. It's looking smaller and also perhaps alpha class. So again, I only see one umbra there for sure. Well, there might be two. Let's see here. I think that's beta gamma class, so I think there is a North Pole umbra there trailing that South Pole umbra depicted in red. As far as these other groups go, let's take a look at this one. That does have some deltas there, so that does have a capacity to produce some significant solar flares. That would be my favorite place to see a large solar flare, besides this area besides this area right here. So this is number 1. This is number 2 to produce an M-class event. But the likelihood's not all that high, folks. There has been a lull in solar flaring. So that's what's going on. And let's move to meteorology. But before we get there, let's talk about the channel. So there are various affiliate/sponsor links. One of them is the Hemp Lucid shop if you're going to be purchasing CBDs, mushroom gummies, and related products like immune stacks from Hemp Lucid. Why not do it through our affiliate link and help support the channel that way? We strive to keep these videos existent, publicly visible, and free for all to view. And we need to get paid for our efforts. So one of those ways is through the Hemp Lucid shop. Links below the video in the description, as well as on the homepage at smashomash.com. A massive web ring that we've built for people like you to receive additional content. Now, you may be worried about disaster preparedness. One of the most important things, and one of the first things that you ought to get, is a battery backup. So this is the kind of one that you would put in your car. This portable power station here by Anker. It's only $220. And, this one could power your aquariums, for example, if your power goes out. There are some larger models there. You can shop at our Amazon shop at amazon.com/shop/smashomash. That is our Amazon affiliate storefront. So check that out. Lots of other products there available in the camping supplies section. There are even whole house battery backups that you can get. Anker, one of the more trusted brands in battery backups. So perhaps check that out. Maybe get a couple different battery backups. Maybe get some solar panels to go with them. Might be a good idea. That one is the 256 watt-hour Anker battery backup. Today's featured merch item, and by the way, save 30% off of the merch items at the Redbubble shop. 30% off of literally everything. Today's featured product is MANSA, which stands for Make America Not Suck Again. Why? Because the best way to get out of a hole, folks, is to stop digging. So, MANSA, Make America Not Suck Again. That is, of course, I'm riffing off of a popular slogan here, and that's part of the reason why we do it, because putting up products that are slightly provocative is a smart idea. I come from the school of Spencer Gifts. Who remembers Spencer Gifts? Let us know in the comments. MANSA, Make America Not Suck Again. It's up to we the people to make America not suck again. You've got to push back against idiotic decisions by bureaucrats. Otherwise, who's going to do it? It's up to people like you. You're paying their salaries, folks. So, yeah, again, the way to get out of a hole is to stop digging. And you ain't making nothing great until you make it stop sucking. Just saying. As we like to cite facts, it's very controversial. Facts. Pardon the controversial facts, folks. Another place to find a lot of facts is at smashomash.com. Again, we launched a massive web ring. And welcome to the Neo-Renaissance. We are not a cult, and we won't ever be forming a cult. So visit our homepage there. You can find all kinds of links and additional content like the Smasho forum. Did you know there's even a dream log there? Yeah, I had a weird dream featuring Dr. Brian Keating early this morning. If you want to read about that, smashomash.com/forum. And if you want to support the channel via subscription services, then become a member of the Smash team. Big thanks goes out to the Gold and Silver Smash team members. They are partially responsible for keeping these videos existent, publicly visible, and free for all to view. The best value is the Gold annual paid-up subscription. As it includes complimentary merch, it's almost like getting 4 months of a Gold Smash Team membership for free. Smashomash.com/Smash Team. Again, links on the homepage to that as well as below the video. There's additional content. It's kind of like Patreon, only better. We built it ourselves. Again, for people like you. And let's move to meteorology. So here's what's going on. This will be an ongoing story. And at the current situation, it has intensified as forecast yesterday. And the first thing we're doing here is we're looking at the world's largest waves. And they are indeed off the coast of Mexico and Baja California. We've got 42 footers out there. So that is quite a significant hurricane at the moment. So that's depicting, the animation depicts surface winds, which are at that area, there are 95 miles an hour. So that is a major hurricane. And yeah, 42-foot waves out there. I suspect there's probably some good surf at the tip of Baja California, as well as, of course, the west coast of Mexico. I am a wave chaser, so I'm interested in this stuff. The pressure has also dropped as forecast. We'll show you that here in a minute. Let's zoom out and show what's going on for winds on a planet scale. So there are the surface winds of the east. Here are the jet streams of the east. And let's go west to check the surface winds of the central world. There you have Africa, Europe, and Central Asia, formerly known as the Middle East. And here is the surface wind scenario for this side of the planet. Strong low here in between Ireland and Greenland. Here is the surface wind scenario for the west. And here is the jet stream. So here's the pressure scenario. We've got all the way down to 972 hectopascals there. And let's show a one-day forecast since we put out these videos daily. So there's a one-day forecast. It is going to move to the northwest and then turn to the north. So there are some huge rain totals forecast here. It will intensify over the next 24 hours according to the GFS model. And the Euro model has it slightly farther north here and slightly shrunken. So the GFS model here predicting a little bigger uptick and a little slower motion to the north. Also keep in mind that sea surface temperatures are involved here. That's not what I wanted. Here we go. There's sea temperature. And that water around there is quite warm. So there is a lot of convective force here. Baja California does not offer a lot of resistance to that wind shear as it is very flat. But it doesn't allow as much convection as if it was over pure water. By the way, it's called Hurricane Hillary, but no, not that Hillary. It's not spelled the same. There's only one L in Hurricane Hillary. And there's a view of the cloud situation. Hurricane Hillary, folks. Not that Hillary. Next, clouds and fog over the Americas. It's the shortwave radiation satellite. It depicts 3.9 micrometer infrared radiation. It'll show you clouds and fog at night. And how about a rare zoom? And there is Hillary. Continuing along to our weather.gov map, the National Weather Service. A heat dome forming over the middle of the U.S. And some flooding in the forecast here for Arizona, Southern California, Nevada, and Utah. Because of that system, which will be a tropical storm by the time it makes it there. It's going to de-intensify in the coming days. Here is your GFS 72-hour forecast. So that's your GFS 72-hour pressure and precipitation forecast. By the time it gets to the U.S., the pressure will rise a lot to about 997 when it makes landfall. And then, of course, it's going to break up as it will lose its access to hot ocean water, which is at like 84 degrees over there. It will, however, bring a lot of rain. So here is our GFS total accumulated precipitation forecast in inches. And you can see some of the totals here, expecting 6 inches of rain there, according to the GFS model. South Central California will be the most significantly hit. southern Nevada there going to see over 3 inches of rain. So that's the scenario. We'll also show the temperature anomaly forecast. That's a 72-hour GFS forecast in degrees Celsius. And here is the jet stream forecast. It's the 250 millibar winds. The 72-hour GFS jet stream forecast. Next, lightning. This is where the lightning's been striking. We did have some additional activity here over Pennsylvania. Arizona seeing some sporadic thunderstorms there as well over the past approximately 10 hours. Let's see if we have any terrestrial strikes at the moment. Lightningmaps.org. Highly recommend it next time you hear thunder. Quite a bit of lightning there over Central Europe. Not so much over the lower 48. By the way, if you enjoy the content, take a moment to press like and subscribe. That's okay, we'll wait. Yeah, I mean you. Yeah, you. Press like, subscribe, press the share button. Leave us a derogatory comment because you're mad about me pausing the video to remind you to press the like button and leave a comment. It's for the algorithms. Which I shouldn't have to say that. That's... Hey, YouTube, recommend the content. Thanks. Thanks in advance, YouTube. We're only the world's most comprehensive daily space weather and most detailed solar imagery in the known universe. We're going to close this mother out with U.S. Doppler radar. This is a series of ground-based systems stitched together that depict vertical motion in the air column. You don't see the hurricane because there are no Doppler radar systems there off the coast of Baja California. It's not because they're hiding data. It's because there are no systems to detect it. Here is our shortwave radiation map for the lower 48. And here is our water vapor map for the same area. Looks like clear skies coming to the mid-Atlantic states there as cold air from Canada is blasting its way down. There is a weak low here, just north of Lake Ontario, right up here. And that is sort of in control, along with this dry mass of air. This dry, cool mass of air making its way down from Canada. Anyway, here's a recap. U.S. Doppler radar. No, those are not chemtrails. No, those are not HARP bases. HARP is not weather modification, and contrails in the troposphere are not geoengineering. Just putting facts out there, folks. Putting out facts. I know it's very controversial to put out facts. There is the water vapor map. That should clear things up if your Doppler is unclear. If you understand the physics, you too can forecast your weather all the way from space down to your earthly place. Anyway, thanks for tuning in to the Smash News Network Space. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.